Hello, welcome to today's lesson on heating graphs. Today we will explore the stages of melting and evaporation by graphing energy and temperature. So far, we have delved into internal energy, state changes, and latent heat. You have learned about how energy is stored within substances, the processes they undergo when changing state, and the energy required for these changes. This lesson will advance our understanding of how heat energy affects the temperature and state of a substance. Let's get started. Suppose we have a graph with energy in joules on the x-axis and temperature in Celsius on the y-axis. We will be using this graph to plot what happens as ice turns to steam. Initially, the substance is in solid form. As we start supplying heat energy, the temperature of the solid increases gradually. This is because the heat energy is being used to increase the kinetic energy of the particles within the solid. The particles begin to vibrate more energetically within their fixed positions. It's important to note that in this stage, the particles are not moving freely. They are just shaking more vigorously. The temperature continues to rise until the substance reaches its melting point. This marks the end of the first stage. When the substance reaches its melting point, an interesting thing happens. The temperature stops rising momentarily, even though we are still supplying heat energy. During this stage, the energy being supplied isn't going into increasing the kinetic energy of the particles. Instead, it's being used to break the bonds that hold the particles together in the solid state. Picture the solid structure. It's like a grid of particles held tightly together. The heat energy helps to break those connections, allowing the particles to move more freely and transition into a liquid state. This process continues until all the solid has melted. The temperature remains constant throughout this phase, marking the transition from solid to liquid. Once the entire solid has melted and the substance is now in a liquid state, we move on to the next stage. In this phase, as we continue to supply heat energy, the temperature of the liquid starts to rise again. Like in the first stage, the heat energy increases the kinetic energy of the particles, causing them to move faster. Particles in the liquid state are freer to move around compared to their solid state counterparts, but they are still relatively close to each other. The temperature increases steadily until the substance reaches its boiling point. Now, when the substance hits its boiling point, we observe a similar phenomenon to that seen during melting. The temperature stops rising temporarily, despite the continuous supply of heat energy. During this stage, the provided energy is absorbed by the liquid to facilitate the phase change from liquid to gas. This is because the particles need enough energy to overcome the intermolecular forces holding them in the liquid phase. Once these forces are overcome, the particles can move more freely and enter the gas phase. Again, the temperature remains constant during this phase until all the liquid has turned into gas. After all the liquid has vaporized and the substance is now in a gaseous state, the temperature begins to rise once more as we supply more heat energy. In this stage, the energy increases the kinetic energy of the gas particles, making them move more rapidly and spread out even more. Gas particles have the highest amount of freedom compared to solids and liquids because they are far apart and move independently of one another. The temperature in this stage will rise steadily until the desired temperature is reached, or until we stop supplying heat. In today's lesson on heating graphs, we explored how heat energy affects the temperature and state of a substance. Specifically, we graphed these relationships to reveal a heating curve, which we understood step by step. By understanding this heating curve, you gain insights into how heat energy is distributed during different stages of heating and phase changes. This knowledge is essential for analyzing thermal processes in both everyday and scientific contexts. Keep practicing with heating graphs to deepen your understanding of energy and temperature relationships in various states of matter. See you next time.